Welcome back to the deep dive. We have a really fascinating find today because we're looking at something that feels, well, it feels very small.
Microscopic in some ways.
Yeah, literally.
Hmm.
But it kind of explains how entire systems work. We are zooming in on a blog called qianmeng.org.
It's a great find. And it's definitely not, your typical polished website or anything.
Not at all.
It feels more like stumbling into someone's private workshop or their personal lab notes.
It does. We're looking at one specific post titled Notes on Fishkeeping, Part 185.
And I think that Part 185 is the first thing that really tells you what you're dealing with.
Right. You just don't get to Part 185 of anything unless you are absolutely obsessed with the tiny details.
That's the key context here. The author, Eng, he describes himself in his bio as an old software plumber.
I love that term.
It's great, isn't it?
Yeah.
And when you read his stuff, you see that mindset applied to everything. He writes about open source software, gardening, photography, and of course, fish keeping.
That phrase, software plumber, really implies this very practical, hands-on approach. You're not just designing architecture from on high.
No, you're in the trenches.
You are actively unclogging the pipes when the data stops flowing.
And that is exactly how he approaches his fish tanks. He isn't just watching them swim around. He's debugging a biological system.
Thousands of posts. This is the person who documents reality with, like, the precision of an engineer.
For sure. And the log we're looking at today is a perfect case study in that whole process.
So our mission today is to unpack this specific entry. On the surface, it's just a story about some fish having babies.
Which, happens all the time.
But underneath that, it's actually a story about unintended consequences. It's about the difference between clean systems and, well, messy ones.
And there's a pretty significant mystery involved, too, with some disappearing tank mates.
A very literal murder mystery, as it turns out.
Unfortunately for them, yeah.
So let's set the scene. Eng is at his outdoor setup. And we should probably clarify, when he says ponds, he's often talking about these large containers he keeps outside.
Right, yeah. Think of them as functional biological reservoirs. They're not, a manicured koi pond with a waterfall.
Got it. So he's out there doing his daily routine, probably checking on things. He's tossing in food, and then he spots something.
Something that wasn't in the plan. A bug in the system, so to speak.
Or a feature.
A beneficial one at first. He discovers a pair of Zebra Cichlids has spawned. And this wasn't just, oh, look, there are some eggs on a rock.
No, this is way past that.
These were free-swimming fry.
Okay, let's pause on free swimming for a second. For anyone listening who hasn't raised fish, why is that distinction so important?
Well, fish reproduction has these very distinct stages where the mortality rate is it's incredibly high. First, you have the eggs, which get eaten by basically everything. Then you have what are called wigglers. They're basically tiny larvae stuck to a surface, still feeding on their yolk sacs. They can't eat real food yet, and they can't swim away.
So they're completely vulnerable.
Totally. But free swimming means they've survived all that. Their yolk sac is gone, they've detached, and they are actively out in the world hunting for their own food.
Means they survive the most fragile window of their life completely unnoticed.
And that's the shock, because normally, if you want to breed fish, you have to be a helicopter parent.
Constantly checking things.
The pH, the temperature, and mostly you worry about the food. But Eng didn't even know they were there. He hadn't prepared anything for them.
And yet he sees them, and they're sticking close to their parents, and they're eating.
Which leads to the first big insight of this whole log.
This is my favorite part. I'm calling it the soggy pellet theory.
It is such a brilliant observation of adaptation. It really challenges how we think about, providing resources.
So walk us through it. He's throwing in these large food pellets, right? Meant for the adult fish.
Yeah, these things are like boulders compared to a baby fish.
There is no physical way they could eat one.
Impossible. And in a normal breeding setup, a hobbyist would be panicking right now. They'd be rushing to the store for special micropellets or setting up a brine shrimp hatchery, which is a whole project on its own.
We tend to think that if we don't provide the perfect, custom-tailored solution, the whole system just fails.
It didn't fail. The fry looked at this impossible-to-eat boulder and apparently thought, okay, I can work with this.
They just waited.
They did. Eng watched them. He saw that the fry weren't trying to attack the pellets. They were just waiting for them to sink and absorb water.
They waited for the food to degrade into something they could use.
He writes that the fry consume the softened bits alongside their parents. It's pure efficiency. The fry didn't need a special new product. They just needed a little bit of time.
It makes you think about how often we over-engineer things. We see a problem. Baby fish can't eat big food, and we immediately think we need a new tool, a new technology.
When nature's solution was just wait 5 minutes for physics to do its thing.
And it wasn't just the pellets.
No, that's the other part of it. He also noticed them grazing on these tiles he had in the pond.
Right, on the algae growing on the tiles.
And this is another piece of the puzzle. He had put these tiles in there, maybe for decoration or shelter, who knows, but they had accidentally become grazing pastures.
Like little farms.
Exactly. Algae is full of microorganisms. For a baby fish, that biofilm on a dirty tile is like a superfood smoothie. It's packed with stuff you just can't get from a dry pellet.
Okay, so we have this picture of a thriving new family. Parents are protecting the babies are eating soggy food and algae. It sounds perfect.
It sounds idyllic, but this is where the software plumber starts digging into the error logs.
Right, because in any closed system, and pond is a closed system, if one process suddenly starts consuming more resources,
Especially resources like space and aggression.
then another process is going to suffer.
And that brings us to the mystery of the vanishing gouramis.
It sounds like a kid's book, but it was pretty catastrophic for the fish involved.
It really was. Aang writes that he'd been noticing the gouramis in this specific pond were perishing, one by one.
And at first he didn't connect the dots.
Which is what anyone would do. When fish start dying, your first thought is usually the water.
And gouramis are generally pretty tough fish, aren't they?
Very tough. They have a special labyrinth organ that lets them breathe atmospheric air, so they can handle low oxygen water, temperature swings. They're not delicate.
So if a tank of survivors starts dying, you look for something invisible. An ammonia spike. A parasite.
A software plumber looks for a bug in the code.
But the discovery of the fry was the aha moment. The bug wasn't in the code.
The bug was the neighbors, the Zebra Cichlids.
Let's talk about that dynamic for a second.
Yeah.
For someone who just sees pretty fish in a tank, why is that such a bad match?
It all comes down to temperament and parenting. Gouramis are generally peaceful, kind of slow-moving. They just sort of float around.
Minding their own business?
Right. Cichlids, on the other hand, are complex. They're smart, and they are fiercely protective parents. When they spawn, they claim territory, and that territory isn't just this one rock. It's everything.
So if you're a gourami just floating by,
You are now a threat. The gourami has no idea it's a threat. It just drifts into this invisible exclusion zone, and the Zebra Cichlid parents just go into attack mode.
so the deaths weren't from a disease. They were targeted.
It was a systemic removal. He writes that the gouramis likely fell victim to the aggressive, territorial nature of the brooding pair.
And he even compares them to another cichlid he keeps, the polar parrot cichlid, because he seems surprised by just how violent the zebras were.
That's a really important comparison. He notes that the polar parrots are generally gentler. They might breed in a community tank, and sure, they'll chase other fish away.
Shoo 'em off lawn.
Yeah, exactly. But they rarely hunt them down to the point of death. Zebra cichlids are different. He calls them notoriously fierce.
There's a really big lesson in that about compatibility, I think.
Yeah.
And about trade-offs.
Absolutely. It's about really understanding the nature of the components you're putting into your system.
You can optimize for one thing. In this case, maybe he's wanted a nice, diverse community tank.
Yeah.
But when a new variable shows up, the spawning, the entire optimization shifts.
That's the perfect way to put it. The zebra cichlids optimized the entire pond for their babies, and that optimization was fatal for the gouramis. The gouramis were a bug that the cichlids decided to patch out.
So he solves the mystery.
Yeah.
But he doesn't stop there. And this is why I like this blog so much. He treats this whole thing as a data point in a bigger experiment.
He does. He immediately compares this outdoor accident to his more controlled experiments.
He mentions he has a control group, right? Another spawn that's happening indoors.
Yes. At the same time, he has zebra cichlids spawning in a standard indoor aquarium, so he's got this perfect A/B test running.
And the results?
The results are stark. He says the outdoor pond population yielded a significantly higher number of fry.
Now, that seems counterintuitive, because we think of indoors as being safe. It's controlled, it has a filter, the temperature is stable.
No predators. Clean water.
Right. The outdoor pond is messy. It's exposed to wind, dust, temperature swings. Why is the wild version doing better?
It comes back to what we were talking about with the algae. It's the food web. In a typical indoor tank, the ecosystem is essentially sterile.
Sterile sounds good, though. We like sterile.
We do, but nature doesn't really. In a sterile tank, the only energy coming into that system is the food you put in it. It's a very simple, linear supply chain.
Human drops in a flake. Fish eats the flake.
And if the human forgets, or the food is wrong, the fish starves. But outdoors,
It's a different world.
Outdoors, you have the sun driving constant algae growth. You have wind blowing in dust and pollen. You have insects. You mentioned mosquitoes and gnats laying eggs in the water.
So it's an all-you-can-eat buffet.
It is a constant microscopic buffet. There's a term for it, infusoria. It's this living soup of tiny organisms that thrive in outdoor water. For a tiny fry that needs to eat constantly, the outdoor pond is a 24-hour diner.
Whereas the indoor tank only opens for 5 minutes a day when the giant hand appears.
Exactly. So the messiness of the outdoor pond is actually its greatest strength. We confuse cleanliness with capability.
That's a great line.
A crystal clear, sterile tank looks good to us. But to a baby fish, it's a desert, a green, murky pond with bugs buzzing over it. That's paradise.
So Aang takes all of this data, the soggy pellets, the dead gouramis, the success of the outdoor pond, and he does what a good software plumber does. He refactors his code.
He pivots his entire strategy for what he calls his propagation projects.
Which is a very formal way of saying making more fish.
It fits his style, but look at the conclusion he comes to. He says from now on, the priority is not the fish.
The priority is the ecosystem.
He writes, we should prioritize preparing tanks with aquatic plants and appropriate substrates first.
First is the key word there. Before you even think about the fish, the users, you have to build the infrastructure.
Which means you don't just fill a glass box with water and drop fish in. You put in your substrate, your gravel.
Yeah.
You put in live plants. And then you wait.
You let it get dirty.
You let the biology boot up. You wait for the algae to grow. You wait for the microscopic life to establish itself. You're trying to bring that outdoor resilience inside.
So the tank already has food growing in it before the hungry babies ever arrive.
It's a total shift from being reactive, oh no, babies, I need to buy food, to being proactive. I built a house that produces its own food.
It connects right back to his identity. He's automating the survival of his fish.
By investing the time up front in the setup, he reduces the manual labor on himself later. He doesn't have to be there every single hour if the tank itself is doing the feeding.
He's engineering laziness.
Which is the hallmark of every great developer.
So true. But there's that lingering shadow here that we have to talk about before we wrap up.
The gouramis.
We can't forget the gouramis. And I appreciate that Aang doesn't hide it. He's very open that this was a mistake. He underestimated the cichlids.
That's that open source ethos coming through again. You document your bugs so other people don't make the same mistake. He didn't just post a cute picture of the babies. He said, I have success here, but it cost me this over here.
It's an important lesson. But it also brings us to a bigger question for you, the listener. Because most of us aren't raising zebra cichlids in our backyard.
No, but we are all managing ecosystems.
What do you mean by that?
Well, think about this gourami trade-off. In our work, our hobbies, even our families, we get so excited about the new fry, the new project launch, the shiny new thing.
The thing that demands all of our attention.
And we pour all our resources into it. We get aggressive and territorial about protecting that new idea, just like the cichlids. But what are the gouramis in your life?
Oh, that's good. What are the quiet, steady parts of your system that are getting bullied or starved out because you're so focused on the new thing?
Maybe it's your existing clients getting neglected while you chase new leads, or old friends you haven't called because you're obsessed with a new hobby. Maybe it's just your sleep schedule getting destroyed for a side hustle.
The new thing might be thriving. The fry might be doing great. But if the rest of the tank is dying off, is it really a success?
That's the question Aang had to answer, and his answer was essentially, no, not at that cost, which is why he's changing his whole process. You can't just optimize for the new. You have to build a system that supports the whole community.
And maybe let things get a little messy. The lesson of the outdoor pond. We try to keep our projects so clean, so indoors, and hidden until they're perfect.
But the data shows that exposing them to the wild, to real-world feedback, to the bugs, is what actually makes them stronger. The mess is where the nutrients are.
So, listener, that's your thought for this deep dive. Take a look at your own ponds. Are you over-filtering everything? Do you need to let a little more outdoor chaos in?
And check on your gouramis. Make sure the quiet, steady parts of your life aren't suffering while you're distracted.
And if you see a soggy pellet, don't just clean it up. Watch it. It might tell you something you didn't know about how to survive.
Observation is the first step to debugging reality.
Thanks for diving in with us today. We'll see you next time.